Hello, my name is Jason Bao from Electrical and Computer Engineering. I'm from University of Florida. This is my EL6512 project presentation. And the name of my project is the Auto License Plate Locating System Design using MATLAB. Okay, here I will introduce the background of my project. With the fast social development, vehicles' number increases significantly. So that means vehicles play more important role in people's life. With that, the traffic management problem becomes more serious, and we need to find a solution efficiently. We notice that the license plate number is a unique ID for each auto, which means um, the license plate of each vehicle is different. So the license plate is a basis to distinguish for each car. And the auto license plate recognition system is designed for this. Here is multiple applications of this system. First, the parking charge management and the expressway charge system, highway monitoring and management system, the urban traffic intersection electronic police in our daily life. The last is residential apartment security. Okay, here is the overall structure of this system. After you get the image, you need to do some image pre-processing. And the next step is a license plate locating part to locate the target license area of the image. And you need to display that image for the further character segmentation and match. Okay, that's the whole structure of the system. But in my design, I will only do the first four parts, and that is the license plate locating system. This is a system for locating the license plate area from the image. The accuracy of the locating determines the quality of further process. Because we need to do the further process, so the output image must in binary image form. The character in plate should be shown as clear as possible. And here I will show you a text result of my system. It's here. You can see we got an image from a vehicle, and this system will show the binary form of the image. And here is the first part of my system, the image get. I took my 3 test images from the parking lots to simulate the situation. And each image must have sufficient contrast and brightness to allow the system to process as expected. If the image's brightness is too low, then the system may not able to recognize the target area in next step. Okay. So next step is image grayscale. You can see the result from here. The image must be read so that the system can get all data for the further process. And to eliminate the influence of color, we need to convert the image to grayscale. The image will only contain the brightness information without color effect after the grayscale. In MATLAB, we can use the image read function to get all data from the picture and use the grayscale function to make conversion. The next step is edge detection. The main effect of edge detection is to accurately locate the edge and the noise suppression. Its basic idea is to use the edge enhancement operator to highlight the local edge in the image, then to define the pixel's edge strength. By setting the threshold to extract the edge point set, in MATLAB, there is a simple function named edge to get the picture and Actually, there are many parameters of this edge, like the Sobo and robots and poets. But in my design, I will only choose a robots operator since the robots operator is more accurate in locating. But it is sensitive to noise because it does not include smoothing. So here is the result image after this process. You can see the three text images become the detour with a white line. Because the robot's operator does not include smoothing, so we need to do that again. The original image is disturbed by various noise during image acquisition and transmission, which will degrade the image quality. So, in order to suppress noise and improve image quality, the image needs to be smoothed. A good smoothing method should not only eliminate the image noise, but also make the image edge contour and the line become blurred. So in MATLAB, I use the image close function that was learned in my class to implement the image smoothing. As you can see from the text result, the license area becomes a white blank rectangular. Oh. From the previous test images, we can see there are numbers of closed areas during image smoothing processing. Those areas must be removed in the image pre-processing, like here. In MATLAB, we need to use image erode function and the BW area open function to have image eroded and remove the small object. We can compare those 6 images. We can see these images are clear. Okay, here is a key part of the system. It's a license plate locating part. Just as it said, the license plate locating is to find the location of the license plate in a vehicle image. That is, computing the edge of the image, and then calculate the projected image of the edge area, probably determine the location of the license plate, and then calculate the image connected domain aspect ratio. Remove the threshold is not within the connectivity domain, and we can get the final license plate area. There are multiple methods of locating as follows. Locating method based on the color feature, based on the transform domain, based on the characteristics of horizontal grayscale variation. But to achieve fast and accurate positioning, the license plate shouldn't be a comprehensive utilization of the various features. Only the single feature is difficult to work. Here is the result images of my design, and I will show this part's code in later of this presentation. As you can see, the license part is shown successfully, but the image we already got is colored, which means it will cost a lot of space and memory. So we need to grayscale that again. Use the grayscale function in MATLAB, and we need to do the binarization. The binarization is conducive to further processing of the image. The image becomes simple, the amount of data is reduced, helps highlight the contours. In this part, different images have different contrast. I need to adjust the threshold for getting binary image with best effort. Like these examples, I set different threshold, and each picture license number is shown successfully. Okay, here is a last step of my system, the filtering. To remove the noise, the filtering part is very necessary. The method I use here is the average filtering. It's a typical linear filtering algorithm which sets a module contains all pixels nearby and assigns the average value to the target pixel. And here is the final result of this system. Okay, now I will show you the MATLAB code here, and I will do a test run. Okay, the image is got, and here is the original picture. I grayscale it first, and I do the erosion, and I try to smooth that image, remove all objects, and yeah, here is a locating part. It's very long. Okay, and now I got the current license area in figure 7. It's here. Yeah, it's here. And I switch that to grayscale again. Set a threshold, and I make the binarization, and finally the filtering part. And I got the result picture in figure 9. Okay, here's the first test. If I want to try the text to image, I need to change the threshold and run again. Okay. Yeah, here is a second test. Yeah, the license number is shown correctly in binary form. And, here is the third test. Actually, this threshold is okay. I just want the best effect. Yeah. Oh no. This kind of part is too dark, so we need to set back to 1.5. Yeah. Okay. I got the correct information image. Okay. Thank you for watching.